And now we're going to say x plus y plus z equals to 3. So x plus 6 equals to 3. So x is equal to -3. So if I've done everything right, the solution should be -3, 2, 4. And the other one was similar to that as well. Okay, how about number 5? Any one of those on number 5? Number 6?
Nope.
Okay, number 7?
Yes, could you please go over 7, please?
Sure. Okay, solve the system by graphing. So I'm going to go ahead and do this one here. So I am going to solve this by, first I'm going to graph them by using the intercept method. Oh shoot, if I can do what I want to do here. Okay, so if I plug 0 in this first equation, if I plug 0 in for x, I get y is -4. And then if I plug 0 in for y, I get x is -2. So the intercepts are 0, -4, and -2, 0. And then that's a lovely line, I know. And then the second line, I'm going to plug 0 in for x, and that'll give me that y is equal to 1. And then I'm going to plug 0 in for y, and I'm going to get x is equal to -2. So in this one, the intercept is -2, 0. And then these lines, if you look at the slopes of these lines, the slope of the first line, and you can kind of look at this. If you had told me that these are perpendicular because they intersect to form right angles, I would have said that's okay. But the slope of this first line, 2x plus y equals -4. So y would equal to -2x minus 4. So the slope of the first line is -2. And the slope of the second line, -x plus 2y equals to 2. -2y equals to x plus 2. So y would equal to -1/2 x plus 1. Whoops, what did I do here? Oh, that's +2, sorry. 1/2 x plus 1. So the slope of the second line is 1/2. And so these are perpendicular because their slopes are opposite and reciprocal. Okay, then this one, number 8, solved by any method. Anybody want to see that one?
Yes, please go and do that one.
Sure.
Just for double checking.
Sure. Okay, so I'm going to go ahead and pick this first one. So if I want to get rid of the x's, I could multiply the top by -3. And that would give me -3x minus 6y equals 0. 3x plus 7y equals 1. And if I add these together, the x values cancel out and I get -6y plus 7y is 1, y equals to 1. And then substitute that back into either one of the top 2 equations. So I'm going to substitute it back into the top one. So I'd get 1 plus 2y equals to 0. I'm sorry, I would get x plus 2 times 1 equals to 0. So x would equal to -2. So the solution would be -2, 0. That's the easiest way to do that one, but there were other ways.
And the solution be negative.
1, I'm sorry, yeah, -2, 1. Jeez. Okay, and then if two angles are supplementary, their sums add to 180. Two angles are complementary, their sums add to 90. And a lot of y'all missed this one. If two angles are supplementary, that means that x plus y equals to 180 has to be one of the equations. And then I'm going to use this one, the 9 times its supplement, one angle. So I'm going to say x is equals 9 times, which would be 9 times its supplement, which is y. So that would be the second equation, x equals 9y. So then you would have 9y plus y equals to 180 if you substitute in. And so that's going to give us 10y equals to 180. So y would equal to 18 degrees. Why that's doing that. And then the other angle, if we said x equals to 9 times y, so 9 times 18 degrees is going to give us 162 degrees. And to check it, you have to add 162 and 118. It should come back to 180. And then number 10, weight of an object on Earth varies directly as the weight on the moon. So the Earth weight varies directly as the moon weight. So it says that a 300-pound object would weigh 48 pounds on the Earth, on the moon. So 300 would weigh 48. How much would a 65-pound object weigh on the moon? So we're wanting to know how much, what's the weight on the moon when something weighs 65 pounds. And then we would just do a cross product. Which is 3120 divided by 300. And you get 10.4. That was one way to do that. Would anyone like to go back over any of the anything else? Yeah.
Let's see, this is one of the graphs I did. I think it was number 2. So I'm not even sure what part I got wrong necessarily, but it said I'm trying because there's all the parts to it. There's like 2A.
Yeah.
I think that one was checked. 2B was checked. I think C is where I started having some issues.
Yeah.
D and E.
Yeah, that's the only thing you missed, Michael. So like if you have f of 3, so 3, so which form did you have, A or B? Did you have
Oh, let me see. Test B.
Okay, so you would be looking at these right here. So f of 3, the number 3, which interval does it fall in? Does it fall in this interval or this interval, or the second interval or the third interval? Where does 3 fall?
Let's see here. Which interval? 3. That would be the middle one, wouldn't it?
Uh-huh. And so on your test, that would mean that f of 3 would be 5.
Okay.
Okay. And then -2, what interval does that fall in?
2 would be
-2.
Oh, -2. Sorry.
Yeah.
That would be the first one, top
Right.
one.
So that means in your on your test, f of -2 would be -2 plus 3, which is 1. And then what interval does 5 fall in?
5. Let's see. That would be the third one.
Right. So on your test, you would say -5 + 9 is 4. And that's it. So you just figure out what interval the number falls in and then plug it into the equation that goes with that interval.
Yeah, because I show the graph here, but I don't even think I never even wrote these down. All I just wrote was points and then I graphed them.
Yeah, that's all. All I wanted you to do was tell me what number it was associated with.
And not graph it.
No.
Oh, well, I guess I just misunderstood it. I don't know.
Yeah, that's what I thought.
Because it's all part of the same number 2 problem. So that's why I was just thinking everything's supposed to be graphed. But
No, those were just like wanting to see if you knew where different points would lie on which interval it would be.
interval. Okay. Okay.
Any other questions on this? Okay, well, if you do at any point look over your test and you're not sure about why something was graded the way it was, or you don't understand it, you can contact me anytime on this and I'll be glad to go over it with you. You will see these kinds of problems again on the final. So make sure that you're going back in. And there's 2 parts to the final. One part is comprehensive and the other part is more like just another test. They both count as the final exam, but if you have a low test grade, then we can replace that low test grade with the part of the final that's comprehensive. So it behooves you to go back and understand if you missed something, especially on a test that you might have made a 40 on or something that you might want to replace. Not that y'all all did that, but okay. So today I just want to real quickly kind of go over what we have been doing. So if you guys will, I'm going to not X out of this time. Go into Pear Deck, if you will. And we're going to do a real quick factoring review.
I don't understand. What are we supposed to like draw a happy face or something? Or?
Oh no, I'll show you in a minute here. Hold on just a second.
Okay.
Are y'all seeing? Okay, I'm gonna start class.
Yes,
I'll show you what I want you to do. I kind of want you to reflect a little bit. Okay, so hold on, let me put this over here. Over here. So this is what I want you to do. So as we go through this, you pick your pencil and make it skinny. I don't know how, this is not ideal as far as I'm concerned because I'm really sloppy drawing with a mouse. So factor the polynomial and then just kind of pick how you would feel if you saw it on a test. So like here, I know this is a trinomial and it has a leading coefficient of 1. So I know that it's going to factor to be, it's going to factor to be x here and an x here. And to get the second term of each binomial, I have to have two things that multiply together to give me negative 24. And at the same time, add together to give me negative 2. And that would be negative 6 and negative 4. So that's how it factors. Easy, easy, easy. So I'm sorry, negative 6.
You mean positive 4, right?
Yes, I did. Thank you. Positive 4. And so I'd go, oh, that was an easy one. I'm going to circle that because I'm going to go back and look at these slides afterward and I'm just going to see, it'll help me kind of just see, okay, this is how people are basically feeling about this problem if you saw it on the test. So let's go on to the next one. Do the same thing. And I can see what y'all are writing over on my screen. And I want you, can y'all write on the, can you write it? I know it's kind of.
Yeah, it has text. It has a text option here.
Okay, good. So if you can write on it, that'd be even better because then I can. So, but I'm seeing a bunch of happy faces. But that doesn't, oh, I'm seeing not all happy faces. Okay. I'm hoping someone does it right so I can show what you did. Yay, I'm seeing a good one. I can't see your names, but I can see a lot of stuff. And what I'm seeing mostly is people are not factoring completely, but I know you're not through yet. Okay, I don't know whose this is, but it's lovely. I'm gonna show it to y'all. So,
That's mine.
oh, that's great. So first she did m squared minus 9 times m squared plus 9. And then she said, oh, but that's not completely factored because m squared minus 9 will also factor to be m minus 3 times m plus 3. And then that m squared plus 9, of course, won't factor because it is the sum of squares. So that is excellent. So let's go on to the next one. And again, this is going to help me when I go back and look at this. I'll say, oh, I can see how y'all responded to this and what you thought as far as whether you really feel confident about it or you are not so confident about it. Awesome. Nice, 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 nice. Most of y'all are doing really good on this one. So again, I'm not sure who this one is, but they sure do a whole lot better writing on this board than I do. So they go, yep, GCF 2, factored out the 2. And then they said, okay, and that's the difference of 2 perfect squares. So that factors to be x plus 5x minus 5. That person should put a big happy face on that. Who did that one?
That was me, Chelsea.
Beautiful. Great. Okay. Go on to the next one. Like this one yet. Okay. All right, hopefully, and well, I was hoping that everyone would do what this person did and just go, oh, I'm so happy she gave me this one. It's prime because there's a plus between the squared terms and you can't factor that. So that one is prime. So if you have a binomial, there's no GCF and there's a plus between the terms, doesn't matter if they're perfect squares or not, it'll be prime. Chelsea, you have the neatest handwriting.
Thank you. I'm on my iPad. It really helps.
Well, yeah, it looks really good. Great. Y'all are doing really nice on this, and I can tell some of y'all really are struggling a little bit. So this is really helpful to me. A lot of y'all are doing it by factor by grouping, which is absolutely, positively, wonderfully fine if you want to. And I see, I'm going to pull this person over and ask them how they did it. Okay, who did this one? Whoops, not, yeah, well, this is good. I'll take, well, I wanted to do this one. Yeah, who did this one?
That was me.
Can you tell me how you did that?
Since A is 1, And I use -6 and 4 to multiply to get -24 and add to get -2. I'm gonna go ahead and skip some steps and plug those into negative.
Yeah,
X.
so, yeah,
When
yeah,
we solve, we get -6 and 4 in the middle, which gives us -2x.
right. Okay, so if it's got a 1 in the front, you can skip all the middle steps if you want. You can just go, okay, what are two numbers that multiply to -24 and at the same time add to -2? And then just write it out, x minus 6, x plus 4. Or like this lovely person did, I mean, they did a great job. They did exactly the same thing. They just did it by factor by grouping and got the same thing. So that's awesome either way. A few frowny faces, so hopefully before Thursday of next week, we'll have you sorted out here.
Yeah, I mean, we have a few days to work on these things. We're
Right.
gonna work on it. So like, if you're not getting them, like it's fine if you're not getting them right now. That's like what this is for. It's so
Right.
much more important that you just try them and like try to like do something.
Right. And I really, I appreciate, I see a lot of people trying stuff, even though they're not sure. And that's what we want. That's what I want you to do. You write something down, because eventually we're going to get you to know how to do this. Okay, I'm gonna show this person's because they're just such a, oh wait, almost, they're not, almost through, hold on. They did such a great job of breaking it down. I wanted y'all to see this. Okay, so first thing they asked themselves, is there a GCF? And they said, no, there's not, yay. So are they perfect squares? No, and it's a trinomial. So they did the AC method and they came up with two numbers that are going to multiply together to give us -3 and add back to -5. Let's see here. Yeah, so they said, I'm trying to figure this out. They got the right things here. So they said 2x² plus x minus 6x minus 3. And then they broke that down. They factored out. They said the GCF of this piece right here was x. So they said x times 2x plus 1. The GCF of this part right here is -3. So that would be -3 times 2x plus 1. So the whole thing's factors to be x minus 3 times 2x plus 1. And this is exactly the thought process I want y'all to go through. I want you, the very first thing to say is a GCF, and then move on and ask yourself more questions about how to go about doing this. And that way I think you'll get the right answer more often than not. Really good. Okay, so I'm gonna go ahead and put one up here. Okay, so GCF, first thing you look for, 3. The only thing this person did not do correctly, and it would be like -1, is see they've got, she or he, I think it's she, has a 3 here, but forgot to put it in the final answer. So make sure you carry that GCF all the way through to the end. It's easy to forget it. I just know. Thanks. I know I do, because I
Can I ask you a question?
Yeah, sure.
Okay, so I have the same issue. I don't really know where to put that number as I'm working through it without it looking funny. Do
Yeah,
we
it
put
does.
like a larger parenthesis or like a bracket or something so that we can contain all of our parentheses or something like that?
That'd be a great idea. Yeah, there really is no, there's multiple ways that you can do that. Yeah, you can put a big bracket if you want to, or just, just remember to carry it
Uh,
over at the end.
As I work through these complex problems, I like to keep everything in front of me so that I'm not,
Yes,
having to go back.
right,
I don't trust myself with for remembering all that stuff.
right.
Yeah,
So,
we like parentheses way too much, and we like soft parentheses way too much. If you want to put some hard parentheses around there, that's usually what I do. If I have too many
Yeah.
soft parentheses,
Like brackets.
yeah,
yeah,
hard
No, okay.
bracket, or you can put like what those. Oh man, I forget what they're called. There's like brackets. There's parentheses.
But let's say like on a test, as long as you guys understand that we're doing this to separate that number, then that's,
sure.
fine.
And actually, as you get into more advanced math, I mean, you see the brackets all the time. I mean, that a bracket is just another form of a parenthesis. So you can always use those brackets to set that 3 off if you want to.
Yeah,
Or
there's parentheses, brackets, and then braces. I think is what you can
braces,
use
and
after
then
that.
even a division bar is considered a separating feature. So yeah. So yeah, just as long as you remember to carry that 3 all the way through. And again, I know it's easy to forget it. You just have to kind of remind yourself and go back and check your work to make sure that that's done. Okay. Big hint here. I don't know if we've actually, I think we have done some like these, but when you factor out a GCF on one like this, make sure you factor out the negative as well. Okay, so when you're factoring out GCF, pull out that negative right off the bat, and that'll make your life easier. And what I mean by that is, like that. Y'all see what I did?
Oh, so you reverse the signs?
Yes, factor out the negative, which will make all the signs be opposite in the trinomial, right? And the reason I put these little happy face things here or sad faces, because I really want you to kind of think, is this a problem that I would have? It might be a way that you can go back and go, oh, that's something I need to look at. That's something I really don't feel comfortable doing. And those are the ones that you want to probably practice on the most. Okay. Looks really nice. So if you factor out the negative 16, if you take negative 16 t squared divided by negative 16, that gives you t squared. 32 divided by t divided by negative 16 gives you negative 2t, and 48 divided by negative 16 gives you negative 3. And then this person said, okay, so now this is a trinomial with now the leading coefficient is a 1. So we just need to figure out two numbers that multiply to negative 3 and at the same time add back to negative 2, which would be 1 and negative 3. So this factors to be negative 16 times t plus 1 times t minus 3. Excellent, excellent, excellent. And I saw a lot of other people doing it very well as well. So if yours didn't look just like that, and you did it by grouping or whatever, that's just fine as well. Okay, last one for today anyway. I see some frowny faces. Sorry. That's okay. I think when you see how to do it, you'll remember.
It was too long ago, too many nights. They slept.
Right, right. Yeah, Gabby, I'm going to show yours just because it's so pretty. Okay. And she did all the way through, which is awesome. I'll show you, some of y'all forgot the very end here. So she said, okay, this is 4 terms, no GCF. So whenever we have 4-term polynomial, we're going to factor by grouping. So she grouped the first two, the m to the third and the 2m squared. And she said, okay, between those two terms, there's an m squared. So she pulled out the m squared and she has m squared times m plus 2. And then she grouped the second set of numbers, the negative m minus 2. And remember that negative, whatever sign is there comes down. That's what's going to be right here. And so she factored out a negative 1. And negative m divided by negative 1 is m. And negative 2 divided by negative 1 is 2. So now she said, okay, now they both have an m plus 2 in common. So she factored out the m plus 2. And she had m plus 2 times m squared minus 1. And if you did this, you're going to get most of the credit. But there'll be this last piece, which is like a quarter of the credit. She recognized that m squared minus 1 will factor some more. So she went on ahead and factored that m plus 2, m minus 1, m plus 1. Okay. So this gave me a lot of insight on some of the problems that y'all are having difficulty with, and hopefully it did you as well. The review that is already posted online has a bunch of factoring problems on it. And I will also post, if you're interested, I will also post some more factoring problems that the more you practice, the better you're going to be. And so I'll post some more factoring problems with solutions so you can check yourself. And then on Monday, I believe Matt is going to be kind of stopping and going over everything we've done so far. And then we have one new little piece on Tuesday. We'll review again on Wednesday, and the test will be on Thursday. So you'll be getting a lot more practice on these before the test.
Yeah, that Tuesday's material isn't a big thing. I mean, it's like we're adding a little something extra to this.
But yeah, but this is the main part. The
But yeah,
extra and
this is the
stuff.
bulk of it.
Yeah. So,
If you can do this, there's just like one other little maneuver we do, and that's like it.
is there any, so again, if you want to be working over the weekend, because there's nothing due this week, after today, I would look at the review and do everything that on that review up till, you'll recognize where you need to stop. Really, we've covered everything except for that one last piece. So that would be good. And then I'll also post under the homework worksheets. It's not due for a grade or anything, but I'll post some practice problems for you if you want extra practice. Is there anything else we can do for y'all? And those of y'all that are coming and participating and doing the homework, I'm so pleased with you guys. I think you're doing great.
Any elements from test 3 gonna be in test 4?
No.
Okay.
No.
Alright, so it'll just cover what we've done between test 3 and test 4 then. Just
That's
those
right.
chapters and that.
Starting with Maricheck 5.2, properties of exponents and scientific notation.
Did we have a test 4 like to review to go over? Because I know that we did that with test 3.
There is a review posted, yes.
Okay, because I'm sure, is it under class documents?
I believe it's under the homework assignments.
Oh,
I
let me
believe,
see.
I think it's at the end of the homework assignments. Look and see if it's there.
Oh, yeah, review for test 4 and solutions. Okay, I got it.
Okay, good.
Thank you.
Yeah,
Thank you.
thanks for pointing
Yeah,
that
'cause
out.
that's really big for me.
Yeah.
Okay, I'm gonna print this.
When's the test again?
It's Thursday.
Thursday?
Uh-huh.
Yeah, Tuesday we'll have one new thing, and then Wednesday we'll review.
And remember, Matt and I are available after class on Monday through Thursday. One of us is here all the time. So if you need extra help, that's the great time to get it. Or if that doesn't work for you, give me a holler or text me or whatever and tell me a good time, and I'll be glad to work with you outside of that time period if we can figure out a good time for you. Okay, guys, if there's no other questions or